Hey guys, welcome to your first flipped lesson of the year. Today we're going to be talking about simplifying expressions. So I want you to imagine for a moment you are walking through the grocery store and you put an apple in your grocery cart. And then you put another apple in your grocery cart, and another apple, and another apple. Is there some way that you could easily summarize what's going on in your cart instead of telling everybody that you have an apple and an apple and an apple and an apple? And of course the answer to that question is yes. An apple plus an apple plus an apple plus an apple is simply 4 apples. And so think about the situation now where we've put 4 apples in our cart and then we add 5 more apples to the cart. And I think you can see where we're going here. 4 apples plus 5 apples is going to lead us to 9 apples. Let's think about a slightly different situation now where we add 7 apples and 2 bananas in our cart. How could we then rewrite 7 apples and 2 bananas to summarize what is in our cart? And the answer to that question really is there is no other way to write 7 apples and 2 bananas. And the reason why we can't write 7 apples and 2 bananas in a different way is that apples and bananas are not the same thing. It doesn't make sense to add the 7 apples and the 2 bananas together. So let's look at a case like this. We have 7 apples plus 2 bananas plus 3 apples. I want you to take a moment right now, because we're going to pause this video in a moment, and I want you to think about, is there a way for you to summarize 7 apples plus 2 bananas plus 3 apples in a slightly different way? Think about that for a minute. Yeah, so of course there is a way to rewrite this. The apples, the 7 apples and the 3 apples, can really kind of combine and become 10 apples. But I want us to relate this to a concept that we're going to be using in algebra, and that concept is something called like terms. When we have 2 parts of our expression that have the same terms, in this case apples, 7 apples and 3 apples, we're able to push those terms together and rewrite our expression in a new way. So 7 apples plus 2 bananas plus 3 apples is going to become 10 apples and 2 bananas. So now let's think about how we can apply this concept a little bit to algebra, because certainly we're not going to talk this entire lesson about apples and bananas. So I'd like you to look for a moment here at this problem. We have 10 squares plus 13 squares. Because both of these are looking at squares, they are like terms. So what do you think we could have as our answer here? How could we rewrite 10 squares plus 13 squares? Yeah, so we can rewrite that as 23 squares, as we have written right here. So if you got that right, you probably have a good concept here of what like terms look like when we're talking about things like apples and bananas and squares. But let's turn that into algebra here. So instead of these squares, I'm going to drop in each square an x. I'm going to read this expression, instead of reading it with squares, as 10x plus 13x yields 23x. And again, the word that we use to describe these two terms in the expression that have the same variables, we call them like terms. So we have 10x plus 13x is 23x, and that's okay because they all are involving the letter x, the variable x. So let's take a look at an example, an actual algebra example. We're out of the realm of fruit and out of the realm of shapes, and we're going to talk some actual algebra. So let's look at this question here. We've got 3x plus 2y plus 5x plus 4y, and we want to write that in a different way. So the first thing we're going to have to do is we're going to have to identify the like terms. So the like terms in this question are going to be 3x and 5x, which I've shown you here in red. 3x and 5x in red, those are both like terms. And the 2y is a like term with the 4y. Once I've identified the like terms, I am then going to move things around in my equation, because ultimately the order that we do addition in doesn't really matter. So let's push these like terms together. Let's rewrite this as 3x plus 5x plus 2y plus 4y. Given that information right there, what do you think the final simplification is going to be? What are we going to write on our final line here? Right, so probably most of you were able to figure this one out. Figure this one out. And it is 8x plus 6y. Pretty simple, really. We're going to move things around that are alike to put them near each other, and then we're going to combine their values. So let's try example 2 here. If we go looking for the like terms in example 2, we're going to see that we have a 3x, we have a minus 2x, and we have a plus 5x. And I've highlighted all of those in red again. And then when we look for the like terms in y, we have 2y and 5y. So we're going to move these things around. And very careful here, I want you to notice that the sign that is in front of a term belongs to that term. So this minus sign is really only applying to this minus 2x. So when I move the 2x, the minus sign comes with it. I'm going to rewrite 3x minus 2x plus 5x plus 2y plus 5y, which we can see right here on this line. And then once again, all I'm going to do is combine those like terms together. I have 3x minus 2x, which is 1x, and 1x plus 5x is 6x. And I have 2y plus 5y, which is going to give me 7y. So I should be looking for 6x plus 7y, which I can see right there in my final step. In example number 3, we've got these parentheses here. So what's going on with these parentheses? Well, if you remember back to order of operations in PEMDAS, the parentheses tell us that we should start with this step. So as we're looking at 3x plus 5, is there anything we can do to combine those two things? Are they like terms? And they're not. The 3 has an x and the 5 does not. They are not like terms. Over here in the other parentheses, is there anything we can do with the 4y and the minus 3 and the plus 6? And again, the answer is no. There's no way to combine those things together. So ultimately, in this particular question, the parentheses don't mean anything. So the very first thing I'm going to do is get rid of them. All I've done here is rewrite the exact same expression, but without the parentheses, because the parentheses weren't doing anything here. Now I'm going to follow the same steps that I followed in the previous couple of questions. I'm going to look for any like terms. So in this case, we have a 3x and a 6x. And we also have, in this case, a 5 and a minus 3. And those are like terms because they share the fact that they have no variable. So we're going to be able to combine those as well. And there's no like term with the 4y. So I've kind of shown you here with colors again where our like terms are going to be. We're going to move those like terms around so that they're close to each other. 3x plus 6x plus 4y plus 5 minus 3. And then finally, we're going to combine the like terms, and we're going to end up with 9x plus 4y plus 2. So hopefully that's kind of making some sense for you. I want to kind of recap here, and I want to talk to you about what makes something a like term. In algebra, like terms have to have two things, and we've only talked about one of them so far. The first thing that it has to have is it has to have the same variable, and that's very important. We're not going to add x's and y's together. But the other thing it has to have is it also has to have the same exponent. And we want to be careful there. And we're going to see in a moment this example I'm pulling up right now, that in this case we've got some exponents. We've got a 7x, but then we've got a 3x squared. And even though they have the same variable, they are not like terms. They are only like terms if they have the same variable and the same exponent. So take a moment right now. Think about what in here, where are our like terms in this expression? Cool. So hopefully you were able to identify some like terms. Let's see if you were right. 7x is going to be a like term with 3x, and you can see that I've moved them together right here, 7x and 3x. A negative 3x squared and 5x squared are like terms, and I moved them together here. Again, be careful. Notice that this negative sign, this minus sign, belongs to the 3x squared, and so it has to move with it when we move it. from this point, now that we have everything grouped together, we're just going to simplify. So if I have negative 3x squareds and positive 5x squareds, I'm going to get 2x squareds. And 7x plus 3x is going to give me 10x. And then I have my minus 11 here. So hopefully I give you a pretty good idea of what we're looking at here. On this last slide I'm going to show you, I have 3 problems that I would like for you to try. I want to see basically what you got out of this video. If you need to re-watch the video, by all means, feel free to do so. Feel free to look through your notes. But I want to see what your thoughts are for how we could simplify number 1, number 2, and number 3. And you're going to enter your answers right here at the end of this play pause it. So stay tuned for that. We will, of course, as always, talk about this lesson tomorrow in class. This is really just meant to be an introduction for you, to get you thinking about our future topic and to help me place you where the best place is going to be for you to be successful with this topic. So do your best on the play pause it, and I'll see you all tomorrow. Bye.